Welcome to the May novice meeting for the Houston Astronomical Society. My name is Chris Morisette. I'm the novice chairman or chairperson rather for the club, and we will be I'll be presenting tonight. The topic for discussion tonight is galaxy season is here, navigating the spring sky. So typically I will do a quarterly talk on the sky that we experience during kind of prime time hours, 9 to midnight during each season. So back in January, we did the winter sky. I usually do this talk in April, but I've been out of town, so Debbie was kind enough to present her topic last month, and then I just pushed back the spring sky discussion till today. So we still have a lot of spring left, so no problems there. So in any event, a little background on what we do regarding our night sky. So we're going to talk about navigating the spring sky. We're going to be talking about using the Big Dipper as our signpost. We have seasonal signposts, and the Big Dipper figures prominently in both the spring and summer. Then we'll dive in after that and do a spring sky tour. So we'll look at some select objects that we can look at through our telescopes or binoculars this season, and we've got some really wonderful objects. And then I'll close out with a few brief announcements. So without further ado, let's talk about navigating the night sky. And what I like to do at the beginning of these talks is just kind of go over some of the basics. And so what I'd like to start out with tonight is to talk about tools. We use apps, we use go-to equipment, and that's great. Apps are a wonderful teaching tool. They're a great way to kind of self-learn. So if you're brand new to astronomy, a phone app is a great way to get started. And go-to mounts are great too, because, as you're learning the night sky, if you are able to get your equipment set up properly, you can slew right to the object of your choice and not have to rely on your navigation skills. However, as you get more into the hobby, at least from my experience, as I've gotten more into the hobby, I've gotten a certain amount of satisfaction out of being able to find my way around the night sky just using my the naked eye, and not using apps or any kind of tables. So that's really kind of neat, because it's at that point that you really, you begin to realize things are really beginning to sink in. So just wanted to share that with you. As you get into the hobby, what you'll first want to do is learn the constellations. So Orion is probably the first constellation I ever learned, and then the surrounding constellations around Orion, such as Taurus, Gemini, Auriga, Canis Major, etc. These are, good ways to begin to learn the night sky on your own. And, one thing, and I'll talk a little bit about this more later on in the slide deck, but if you are familiar with the zodiac signs, you've got a head start on the process, because the zodiac signs lie along the ecliptic. And if you know your zodiac signs, you already know 12 of the constellations. And again, I'll show that in a little bit more detail here in a second. One of the things that I learned or kind of grabbed onto as an aid was to learn the bright stars. And so, and this was a technique I used in order to begin to tell which constellation I was in. In a light polluted area in Houston, or even in the suburbs, it can be difficult to tell exactly whether or not you're in a constellation, because viewing all the stars may not be visible to kind of put the pieces together. So if you can identify and get to learn those really bright stars in the night sky, that'll give you an idea of where you're at. A great example is Sirius. It's the brightest star in the night sky. And if you can find Sirius, which is, really easy to do even in a light polluted area, well, you know already that you're in Canis Major. And from there, you can begin to kind of sort out and find the other stars and, put together the pattern that represents the constellation. The same goes for Orion. That was, again, from my experience, finding Rigel and Betelgeuse were very easy. It was very easy to do, even up here in Kingwood. And then once you had those, you had kind of the shoulder and the toe of Orion, and you were ready to kind of put the rest of the pieces together. Now, Orion's a pretty easy one to sort out because you've got those three bright stars as the belt. But you kind of see where I'm going with all this. Stars like Spica, Vega, those stars, if you can find those, you got a kind of a leg up on figuring your way around the night sky. As well, even if you're out at the dark side, you can kind of get overwhelmed with the number of stars that are out there as well. You may be asking yourself when you first start out, well, gee, there's so many stars out here, I really can't tell where I'm at. And here again, these really bright, colorful stars can help you, get your bearings. There's some great resources out here. There's a children's author called H.A. Ray. He wrote the Curious George books, and he also put together a couple of books on astronomy, Find the Constellations and the Stars. And these are geared for children, but if you're just starting out, they're really apropos for older people that are just getting started in astronomy. So don't shy away from it just because he's a children's author. He puts out the information in a very simple and understandable way. One thing he does that I really liked in his book on constellations, what he does is he connects the dots, or stars rather, in ways that make the pattern of stars look more like the mythical name. So let's go down here to Virgo, which is going to be one of the areas of importance to us during the spring. This is kind of a normal depiction of what Virgo would look like. And again, he's not changing the pattern of the stars, but rather what he's doing is he's changing the connection between the stars. And in his representation here, it looks more like Virgo, who is reclining, is a woman that is reclining. I don't know the full myth behind her, but that is that's the idea here. The whale constellation is another good example. So over here is an old time representation of what the whale constellation would look like. And if you see over here, he's connect the stars in a way that makes it look much more like a whale. So bottom line with that is this is a great reference. Now, as you get more experienced, and in particular, if you do a lot of visual astronomy where you're star hopping, going and using some of these atlases and reference manuals, you're going to want to be able to do that because you're going to get a lot more detail to help you find more obscure objects and study. You're going to be able to study more obscure patterns of stars out there. So these are some good references that you see here. I know the Pocket Sky Atlas is a very popular reference. And here again, as you dive deeper into the hobby, these will become more and more important. I'll put in a plug for this. If you know me, you know I'm going to talk about the Deep Map 600. Again, if you're just starting out, this is a wonderful reference. It's a kind of like the old gas station map. It folds up into a very neat, thin package. You can unfold it. On one side, you'll find the map of the night sky with a lot of common objects, interesting objects that we all look for, shown on that map. And then if you flip the thing over, you get this wonderful table that has a short set of information about each of the objects that are on the front of the map. Now, the level of detail is relatively thin. I mean, you get the RA and deck coordinates, the magnitude, the constellation the thing is in, kind of object it is, and a short comment. But it doesn't overwhelm you. So I think it's a wonderful tool. I like to just open this thing up over morning coffee and kind of peruse it, and just kind of look at some of the areas of the sky that maybe I haven't had an interest in, and see what kind of interesting objects are out there. So, and it's for $15. I think it's a wonderful value. I found another one here called the All Sky Map, which is, it's got some attributes that are a little bit better than the Deep Sky, but it doesn't have that detail that the Deep Sky has on the different objects. The thing about the All Sky Map is that this has the entire night sky. So if you are venturing into the southern hemisphere, you're going to be able to see what that part of the sky looks like, what the objects are down there. And again, it's a great learning tool. On the back side of this, you have kind of the celestial poles for both the north and the south, which kind of gets truncated on the previous section. So they kind of blow it up into a separate diagram here. And I didn't point this out, but back in the deep map, you have the same thing. The deep map is really geared for the northern hemisphere, though. So anyway, another one to consider when you're looking for tools. Planispheres are great too. Again, these are kind of a nice tool to be able to get out there, and it's good for really any time of the year. You kind of turn the dial to line things up with the time of year and the time at night that you're observing, and then from there you can get a depiction of the night sky. Another tool that's really good is the sky map that you can get from skymaps.com. Highly recommend this one. They have a new sky map for each month that's available for download, and it's completely free. And it's kind of a simplified map, but a very useful map to kind of get you going. And so what I've got here is the front page. There's a 2-page document, and this is the first page that you'll get. And you'll notice that I've got red circles around various objects that are here, and these are some of the objects that we're going to discuss tonight. So I put those on there. The sky map did not come with those, but you can see various objects of interest here that you can use to figure out which you want to go look at. Now, if I'm using this map, what I'll do is I'll go out onto my driveway, and if I'm facing south and looking up into the sky, I would want to have this map pointing down so that south is pointing towards the ground. And then this is what the sky would look like when I'm looking south. Okay. Now, when I'm looking north, if I turn around 180 degrees, what I want to do is I want to take that map and turn it upside down so that north is facing the ground. And then these are the constellations and the night sky that I'll be looking at. And you can notice up here, Ursa Major, which has the Big Dipper, is very prominent up here, along with Ursa Minor and some of the other northern constellations. So again, this is if you're just starting out, you're not sure you really want to spend any money. This is a great way to get your feet wet. You can use this in lieu of an app, or you can use an app. It's your call. But again, another reference that I think would be useful to take advantage of. Now, this is kind of our model of the cosmos that we use, which is called the celestial sphere. And it's nothing but an imaginary sphere that kind of parallels our own Earth. So you'll notice that the celestial sphere has an equator, it has a north and a south pole. And this equator and the north and the south pole parallel our own. So our equator is parallel with the celestial equator. The poles are parallel, so on and so forth. There is a coordinate system that is used to denote the kind of a non moving location for any kind of star, any a nebula, any galaxy, and this coordinate system is called right ascension and declination. And so right ascension is analogous to what longitude would be here on Earth. Declination would be analogous to latitude. There's also this thing called the ecliptic that you'll notice is at a 23-degree angle here. And this is the plane in which the sun and the planets, in which we'll find the sun and the planets residing on. So that is the ecliptic. And this is our model. Now, I mentioned earlier about astrology, and what I was getting at when I mentioned that is that the ecliptic, there are a set of constellations that reside on the ecliptic, and those are the zodiac constellations or the zodiac signs. So, Gemini, Cancer, Leo, Virgo, Scorpius, Sagittarius, Capricorn, Aquarius, Aries, let's see what else, Pisces, Taurus, Gemini, all those reside on that ecliptic. And again, if you're familiar with astrology, if you've ever looked at your horoscope in the paper and you're familiar with these signs, then you've got a leg up on the constellations. And if you remember that they're on the ecliptic and they go in the same order as they do in a horoscope, boom, you've got 12 under your belt. There's one called Ophiuchus that is over by Sagittarius, and it is not on the it is on the ecliptic, but it is not a zodiac sign. So just kind of remember that one. It's kind of a special case. One other thing to point out here too is that the North Star or Polaris is going to change as our latitude changes, our position on Earth changes. So if you're at the North Pole, the Polaris will be up over your head. And as you move farther south, say to Houston, where we're 30 degrees north, we'll see Polaris at 30 degrees above the horizon. So the thing to remember is whatever your latitude is, that will be the altitude off the horizon that Polaris will reside. So if I'm up in, let's say San Francisco, which I think is at about 38 degrees north, then I would find Polaris 38 degrees. If I'm in Houston, it's 30. And if I'm down in Corpus or Brownsville, it's going to be somewhere in the 20s. So just one thing to remember. Again, if you're at the North Pole, stars will appear to circle your head, but as you move farther south, stars will appear to rise from the horizon, come up over your head, and then set, much like our sun. So just a little bit more about our orientation. There is this where you see Polaris. Another kind of interesting feature is that stars and constellations that are in Houston, within that 30-degree that 30-degree horizon, they will never set. In other words, they're always up in the sky. We can't see them in daytime because of the sunlight, but they're always there. Okay. Constellations and stars that are farther out will eventually set, but those that are within 30 degrees will not. And again, as you move farther north, you'll have a wider larger number of stars and constellations that won't set. And then this kind of provides us with some really good photographic opportunities. Here you see a picture from Texas Star Party out in West Texas, and this is showing star trails. So if you put your camera on Polaris and you open the shutter and leave it open for minutes or hours, you'll begin to see this nice circular depiction of all the stars and the trails that the stars will leave behind. So it's kind of cool, a neat effect. A little bit more about we'll kind of ease our way into the Big Dipper. One thing about the Big Dipper, it's a very handy way to find Polaris. So if you can see the Big Dipper, and we use the Big Dipper because those stars are very easy to spot. They're bright and they have a very distinct pattern. But if you find the Big Dipper over here in the end of the cup of the Big Dipper, and you follow a line from the bottom star to the top star out, you'll eventually get to Polaris. So that's kind of the first usage of the Big Dipper as a signpost that we'll discuss tonight. And then here is the Alaska flag. It kind of shows it a little bit more broad, or a little bit more boldly. But here is the Big Dipper. And then again, you're pointing out to Polaris using those two end stars. Okay, so here is the Big Dipper. And I've got this picture here that's really nice. This shows you the position of the Big Dipper during each season during the early evening, or what I like to consider primetime viewing. So, 8 o'clock to 11 o'clock, that kind of thing. This is where you can expect to see the Big Dipper. And in springtime, you'll notice that the Big Dipper is very high in the sky. So it makes for a very useful and handy signpost. And that way we can use the star patterns to navigate to different parts of the night sky. In the summertime, we have the same, not exact same situation, but it's still high enough in the sky we can take advantage of the Big Dipper. In the autumn and winter, you'll notice that it's down closer to the horizon, so it's really not that useful. However, we've got other constellations that are up that can provide us with a way to, find our way around the night sky. One other thing that I did want to hit on before we got into the signpost of the Big Dipper in more detail is the North Star. We have our Earth is actually spinning on its axis, but the axis is actually moving as well. So our pole, the pole of the Earth is actually moving around this thing called a precessional circle, and it will move around this circle once every 26,000 years. So what that means is that the North Star that we see today will not always be there. And in about 13,000 years, and I think this is on another slide, but let me go to this slide here. This shows you kind of that movement around that precessional circle. And this is just kind of what a top or a gyroscope would do as well. So we're wobbling in effect, but it's very slow. And of course, over our lifetime, we're always going to have the North Star, but later generations won't. And then this is the picture here that kind of shows you where we will end up. So right now we're on Polaris, and in about 13,000 years, we will have Vega as our North Star. And this is kind of interesting because in my study, we won't call it study, but a research that I did for another presentation a while back, I looked at the Egyptians. They made very extensive use of astronomy in their culture, and the pyramids were constructed so that they were pointing at the North Star. Now, if you go and look at where the pyramids are pointing today, they're not pointing at Polaris. They're actually pointing at a different point in the sky. But remember that the Egyptians and the pyramids were constructed about 5,000 years ago. So that's a material amount of time. and that would represent a different spot in the sky that they would have been looking at for their pole star. So just kind of an aside there. There's another thing that goes on called nutation. So while the pole of our Earth is moving around the circle, it's also making a little squiggle here called a nutation. And because of that, and that's a more frequent phenomena or occurrence, because of that, we need to update, star atlases, things like that I guess it'd be about every 50 years or so. Now, with everything being so computerized now, it's not such a big deal, but back in the day when things were predominantly paper, it was a bigger deal. One last thing on just navigating the night sky, you can use your hand and your fingers to measure distances. So if you hold your hand out at arm's length and you look at your pinky, that width of your pinky is going to represent 1 degree. 3 fingers is going to be 5 degrees. Fist will be 10 degrees. Hook'em horns will be 15, and then the Hawaii Mahalo sign will be 25. So if you're getting into, if you really want to challenge your abilities to find your way around the night sky, knowing these hand thicknesses, finger thicknesses will help you measure distances. Okay, now let's talk about the Big Dipper as a signpost. So you may be asking yourself, what is a signpost? So this is what we had in the winter, which is Orion, and here you can see that the various stars in Orion can get us to different spots in the night sky. So we could get to Aldebaran, Sirius. We could go up here, use Rigel and Betelgeuse to get to Pollux and Castor and Gemini, so on and so forth. And so we have the same situation with the Big Dipper. This picture right here shows you a map of the entire night sky. And what I've done here is with this green box is I've kind of, placed this green box over that section of the night sky during the springtime that we'll be seeing in prime time, which again would be 8 to 11 at night. You'll notice over here Cassiopeia and Orion, and then over here the Summer Triangle and the Teapot. These are other signposts that we can use, but those will be more geared towards summer and fall and winter. So this is the Big Dipper is really the main signposts that we will use here during the springtime. So a little bit more about, what, so you've been saying signpost all night. What do you mean by that? So, what I mean by that is a signpost is really, again, it's either a constellation or an asterism, which is a subset of a constellation. The Big Dipper is not a constellation. It's really a part of Ursa Major, so it's really an asterism. But it's a pattern of stars, and it's a pattern of stars that we can use to navigate to different parts of the night sky. So we talked earlier about how we can use the end of the cup to get us up to Polaris, right? So that's one way we can use it. We can also use the handle of the Big Dipper to do something called arcing to Arcturus. And Arcturus is a very bright star, and we'll talk about how you can arc to Arcturus. You can also use the interior of the cup to move down here and navigate to Regulus. And then you can also use the inside top of the cup and the outside bottom of the cup to get down to Castor. You can use this to get out to Capella, the top lid of the cup. You can follow those stars. So the pattern of stars and the lines that we can draw can take us out to different parts of the night sky. And that's what a signpost is. Here's what I meant by arcing to Arcturus. So here we kind of are drawing a straight line off the end of the cup, but what we're doing is we're just using kind of a saying, if you will, arc to Arcturus, to kind of remind us that we need to use this handle. So what we would do is we would just follow along these stars around the arc of that handle, and then that would bring us down to this really bright star called Arcturus. And that's, again, getting back to those that listing of stars that I showed you earlier. Arcturus is one of those bright stars that we can easily recognize in the night sky. The other thing, too, along with being bright, it's a very reddish star. So we can make a distinction between that star and other surrounding stars. Okay, so we can arc to Arcturus, which will put us in a different part of the night sky. And then we can do another thing called speeding on to Spica. And Spica is a prominent star in Virgo. And again, that's a very easy star to find because it is very bright. And since we're in galaxy season, getting down to Virgo is really important because there's a lot of neat things to look at, a lot of neat galaxies to look at that are in that part of the night sky. Okay, so let's talk about some of the objects that are available to us. But first, let's have a little chat about galaxy season. Why is spring galaxy season? Here's just kind of a short primer on it. This diagram is pretty busy, but it tells a really important picture. So here is the Earth right here, and this is our orbit around the sun. Okay, and at each point on this diagram, you'll notice that the Earth is at different points of its year. So down here is wintertime. We are on the other side of the sun from the center of the galaxy, and we are looking out towards the edge of the galaxy. We're still in the dust and gas plane of the Milky Way, where there is a high density of stars, but we are looking out towards the edge of the galaxy. When we get up here to the spring equinox, or for just in general purposes, springtime, we're up at this point here, and what you'll notice is that we're actually at a position where we're looking through a less dense star field, and because of that, we're able to get a more direct view out into deep space. The other thing, too, is that at this position, we are able to look out and see a very rich area in galaxies. So we're looking through a less dense star field, and we're looking out towards a patch of the sky that is just chock full of galaxies. That's why they call it galaxy season. Down here in the summer, we're back over on the other side of the sun, and when we get into nighttime, we're looking back towards the center of the Milky Way. And then that, of course, that's summertime's when you see all these really beautiful Milky Way shots where you see the core of the Milky Way and it's very bright, and that's kind of a neat thing. You don't have that. You've got a high density of stars you're looking at, unlike springtime. So, but that's kind of the unique thing about the summer. And then down here in the fall, we're a little bit back towards looking out into deep space. We don't have that target rich area like we have in the springtime, but there are some neat things to see in the fall. So that's kind of why we call it galaxy season. And again, the Virgo cluster is really in primetime viewing for us. And I don't know if you can really make it out too well on this slide right here, but you'll notice a bunch of blue spots. Those represent galaxies. There's just a tremendous population of galaxies here. We're going to look at some of those tonight and talk a little bit more about those. So that's kind of a little background on why we call that galaxy season. Okay, so let's start looking at some of our targets. And we're going to start out with a real easy one, which is Alcor and Mizar. And Alcor and Mizar are the center stars of the Big Dipper handle. And this, so when you look out with the naked eye, you may say to yourself, well, gee, there's just only one star that's at the center of the handle. Well, if you look close enough, or if you get a pair of binoculars out, you'll notice that you actually have two different stars. And so it is a double star. This object is about 82 light years away. And it's a great way to start out because a very easy way to start out. If you can find the Big Dipper, which I think most of us can, you should be able to find the center star of the handle. And if you have binoculars, you can look and resolve the two different stars. I haven't looked at it in a while. I believe they are of different color. So that is another neat thing about Alcor and Mizar. So again, a very easy, straightforward way to start out. And I would encourage everyone here to give that one a shot because that'll be a good one easy one to notch under your belt. Next, staying up in the Big Dipper area, there's a really cool galaxy up here called M51, and it is approximately 3.5 degrees below the end of the Big Dipper handle. So we really don't even have to use the signpost to move around. We can stay within the signpost of the Big Dipper, and we can find M51. So let's look at a picture of M51, which is the Whirlpool Galaxy. And this is a really interesting object. This galaxy, and M51 is the main large spiral galaxy that you see right here. It's about 28 million light years away. And to just kind of put that in perspective, the diameter of the Milky Way galaxy is 100,000 light years in diameter, and this object is 28 million light years away. So it is a very far distance away from where we are at here in the Milky Way. So it is an object that is materially farther away than most of the things we see during the winter and the summer. This particular galaxy is about the same diameter as our own Milky Way. It is a spiral galaxy, and you'll notice that there's this interaction here with a companion galaxy called NGC 5195, which you see down here. And there's actually some kind of a transfer of material from this galaxy over to this galaxy. Now, the interesting thing about this is that, when I first saw this, I thought, well, how unusual, how unique, that two galaxies would actually be interacting with each other. Well, it turns out that's a very quite common occurrence. We'll see a couple of more examples here tonight. But that is, galaxies are always colliding with each other, reforming and creating something different, or one galaxy actually, in this case, stealing material and actually destroying its companion. So this is a common occurrence. You see it out there a lot. And that is a very interesting phenomena. So, and this is a very good example of galaxy interaction right here with M51. Another galaxy that's up near the Big Dipper is M101, and it's about 5 degrees above the Big Dipper handle. And it is at about a distance of 23 million light years away, and it's about 1.5 times the size of our own Milky Way. And this is a wonderful depiction of M101 that I got from Jeff Lepp. And Jeff is a wonderful astrophotographer, and this is his rendering of M101. And what you'll notice here is there are some star forming regions that you can actually make out. So like right here, right in here, right in here, you can see even at a distance of 23 million light years, you can even delineate the areas of star forming, the star forming regions. So again, another great object to go and view. One thing that I will say here is that, of course, this is a processed astrophotography image. If you go out and look at this through a telescope, and you're going to need a fairly big telescope, preferably with dark skies, you're not going to see this color and this detail. You'll see some of the detail, but it's going to look more like this. It's going to be more black and white, a little bit more faint and fuzzy, but you'll be able to recognize the pattern. I wouldn't let that dissuade you from going out and trying to take a look, because it's really cool to see these objects naked eye, through, well, not naked eye, but, with your own eye through the eyepiece of a telescope. So that's M101. Next, we will go on to one of my favorites, M82, M81, and M82. And in order to get there, you want to go off of the end of the cup. You're not going to go in a straight line like I showed earlier, but you're going to make kind of a somewhat of a tilt here, and you're going to go 14 degrees that way. And when you do, you'll get to this pair of galaxies that are really quite striking. So M81 and M82 are about 12 million light years away from Earth, and they are 74,000 light years and 37,000 light years in diameter, respectively. So M81 being the larger galaxy over here is 74,000, and M82 over here is 37,000 light years in size. So you'll notice here we're looking at M81 face on, or relatively face on, so we can see the nice spiral design, the nice spiral look. Here with M82, we're looking edge on, so we're not able to see, the galaxy like we are with the two that we looked at previously, and with M82 or M81 rather. So that is kind of a unique thing. Now, here is another great example of galaxy interaction. So there is spacing between these two, but it's not a lot in galactic terms. So the gravitational effects from M81 are being felt on M82, and vice versa. But M82, being the smaller of the two, is really getting the effects from M81. And you'll notice in here, there's a kind of a red crease right here in the center of M82, and that is a starburst effect that is resulting from the interaction between these two galaxies. And what that is an accelerated or rapid star formation phenomena in M82. So these two haven't yet tangoed, so to speak, like M51 and its companion, but they're beginning to feel the heat from each other. So that is, again, another example of where galaxies can and will interact with each other. And I think it's a great example of that. If you go out and look and you've got the right telescopic equipment, you can probably see this in one field of view. But either one on its own would be wonderful to look at. So again, something to take a look at during the spring galaxy season. Okay, so next we're going to move into booties. So remember, when we arced to Arcturus, and I guess you can see it up here, that's the handle of the Big Dipper. When we arc, we're going to make this straight line beeline to this bright star called Arcturus. And Arcturus is in this constellation called Bootes. And right next door in Canes Venatici, and I'm not sure I'm pronouncing that right, is a globular cluster called M3. So let's take a look at M3. M3 is about 10 degrees from Arcturus. So if we're at Arcturus and we go up here about 10 degrees at, say, 2 o'clock, we'll be able to get in the neighborhood of M3. This globular cluster is about 32,000 light years away and is about 11 light years in size. So it's not a very large object itself, but it is at quite a distance. And you'll notice here that this is very, for those that are uninitiated, a globular cluster, unlike an open cluster, is a very tightly packed, dense collection of stars. And in this particular example, we're looking at stars that number somewhere in the neighborhood of 500,000. So an open star cluster may have hundreds to thousands. Globulars can have, tens of thousands to almost a million stars. And so they're very cool to look at. They have a very bright, dense core. And then the stars you can see in the outer periphery, you can begin to resolve. They're very beautiful objects. This particular object is very old. Globular clusters are typically old objects. M3 has the distinction of being where this star called a blue straggler was determined. And a blue straggler, and I'm going to cheat a little bit here. I looked it up before I started the meeting, and I'm going to cheat because I don't want to get this wrong. But a blue straggler is they call it an anomalous hot blue and luminous star found in old stellar clusters, and they appear to be much younger and more massive than their neighbors. So the idea here is that these blue stars, because these objects are so old, you wouldn't expect to see these massive blue stars. And the theory is that these stragglers were created either by the merging of two stars or by one star siphoning off material from the other. So that's kind of an interesting phenomena. These clusters are relatively gas poor, so they're not like, say, Orion, where you have a lot of material to build stars. These are old clusters of stars that have consumed their original material to create stars, and so they're gas poor. These stars you wouldn't expect to see because they're blue and they're massive, and that would denote a star that would have be a relatively new star in an old cluster. But the way they're created allows these stars to be in the same population as these older red giants. So anyway, I thought that was kind of an interesting aside and kind of M3's claim to fame here. These clusters can be 11 billion years old, so really not much, almost as old as the universe itself. So that's pretty cool. Now, one thing about these globular clusters is that they're at distances that are, they're part of our galaxy, but they're at distances that are much longer than what we would see with, nebula that we see during the winter or summertime. The Orion Nebula is about 2,000 light years away. This cluster is about 32,000 light years away. And one of the reasons why is that globular clusters tend to live up here in the halo of the galaxy of our galaxy, and they are gravitationally bound to the Milky Way, but they reside up here and actually will orbit around the center of our galaxy. So that's kind of a unique feature of globular clusters, and we've noticed also with our nearest large neighbor Andromeda, a population of globular clusters that are up in and around the halo of Andromeda. So kind of a unique feature of globular clusters. Okay. Let's get back to some galaxy action. We're going to start out and we're going to go to Virgo, and we're going to first look at this thing called Markarian's chain. So you remember we arc to Arcturus and then we speed on to Spica, and Spica is down here in the constellation of Virgo. And Virgo is very rich in galaxies, and you'll notice up here at about 1 o'clock from Spica, quite a collection of galaxies. And it's in this neighborhood right up here that we have this collection of galaxies called Markarian's chain. And here's a really nice depiction of Markarian's chain. And you can see here this number of individual galaxies here, 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 trailing off into the distance. It's almost kind of like that deep space image that Hubble took here a number of years back, where they just kind of pointed the camera into what they thought was a vacant part of the sky, and once the results came back, they were shocked to see just how many galaxies were out there. This is sort of analogous to that. We're looking out into deep space, and we're able to see what would look like stars, to an untrained observer. But what we're really looking at is a collection of galaxies, and I think it just kind of points to the massiveness of the cosmos out there, and how many objects can be out there. And the Markarian chain is a great picture, is a great thing to go try to view, because you can see so many galaxies in one view. And so that's Markarian's chain. Another really cool one is the Sombrero Galaxy. And I'm going to go back up here real quickly. So once we get to Spica, we can come over here at 3 o'clock. And when we do that, it's about a 7-degree trip from Spica over here. So it's relatively close. We can get to the Sombrero Galaxy. And that's the Sombrero Galaxy. This is a classical edge-on galaxy. And it's really cool to look at. You've got this very distinct opaque dust lane right here that is kind of backlit by the core of the galaxy right here. And they call it the Sombrero Galaxy because it looks somewhat like a sombrero that you would see in Latin America or Mexico specifically. And that's where it got its name. This is about 28 million light years away from us. It is about 69,000 light years in size, so it's smaller than our own Milky Way. And again, this is a great example of a edge-on galaxy right here is the Sombrero Galaxy. And very nice image here from Brad Burgess. Another item that we can look at is an open star cluster. This is M44, which is the Beehive cluster. I didn't put in here a map. Let's see if I can come back up here. It's actually in I can't see it. It's in the constellation of Cancer. So it's a little bit before you see Virgo on the ecliptic. So it's in Cancer, and it is a relatively easy star cluster to find. With binoculars, it's very apparent. You're looking at a star cluster when you see this. Last spring, we had a novice lab out at the dark site, and we were fighting clouds all night. Mars was in close proximity to Cancer, and because Mars is so bright, we would, point our binoculars right there, and if we just did a little looking around, we could find the Beehive cluster. So this is a really nice object to go after, very colorful, and open star clusters for me are a little bit tough to find. This one is very apparent, almost as easy as Pleiades, maybe not as easy, but again, it's a really great target to go after. In binoculars, it's a wonderful view. Okay. And then the last item that we'll look at here is the Leo triplet. So this is made up of 3 different galaxies, M65, M66, and NGC 3628. And they're all roughly about 40 million light years away. I believe this is M65. I believe that's M66. And I know this is NGC 3628. Again, you've got galaxy interaction happening here. You'll see some warping here of the dust lane. Again, this is an edge-on galaxy. And again, this is another great example of being able to get kind of a 3-for-1 deal on your observing, because these are relatively close together. If you can't get them in one field of view, you don't have to move your telescope very far to get the other 2 galaxies. So this is great. It's in the constellation of Leo. And again, I neglected to put a map in there, but you find Leo. We showed how you can navigate down to Regulus, which is one of the stars in Leo, and that should get you in the ballpark. Okay, so that is the sky tour. Those are some just examples of some objects that are worth going after. I put in here the second page of the sky maps. and I've kind of drawn a red box around some of the objects that we talked about tonight. Not all of them are listed here, but this second page out of Sky Maps will give you an idea of what you need in order to see these objects. So M44 with binoculars, really good. When you get down to the galaxies, you're really going to need a telescope. And people ask me all the time, well, how big of a telescope should I have? I would think for these galaxies that we looked at tonight, you're going to need something in the 10-inch range or higher. And good Dobbs out at the dark site would be your best bet for finding these objects. So that's it. Another way to go look is by using a smart telescope like a Sea-Star. Those are handy to go find some of these more obscure objects if you're just starting out. So this is again out of the second page of Sky Maps, and not only does it cover what we talked about tonight, but there's some other ideas in here for objects that you can go look for. Other celestial events that are coming up are listed here on the first page of the Sky Maps. There's a lot of them here. The Eta Equard's meteor shower peaks are probably the most prominent of the events coming up this month. So you might want to keep a lookout for that. Unfortunately, the moon will be quite illuminated during the peak, so you may not see a whole heck of a lot. But again, if you like meteor showers or want to give it a shot, the front page of the Sky Maps can give you the details that you would need. Okay. So with that, I encourage you all to get out there and stargaze. It's a wonderful season. We have I think we're still doing our prime nights out at the dark site during the middle of the month. I would encourage you to come out there, and they usually have the observatory opened up. You'll have a lot of people with their telescopes out. So if you're just new to the game, getting out there and just asking somebody what they're looking at, and if you can take a look, people are very generous and open and love to share with their telescopes. So it's a great idea to get out there. In May and June, I should be out there myself, so we can do some sky tours as well. So use that as an opportunity. And then I'll just wrap up here quickly before we go to questions. We have our SIG meetings coming up listed here. The VSIG is next Wednesday, Smart Telescope SIG, a Wednesday after that, and the Astrophotography SIG on the 27th. So if you look on either the website, I know Matt typically sends out an email with the information in it and the links. Look for that and join us if you can. And then one last thing I want to say before I go to questions. I have been in Australia the last month, and I went down there not only to have fun, but also to get some great material on the southern hemisphere and the skies down there. I was able to, I think, get a lot of really good material that I brought back, and I plan on putting together a tour of the southern hemisphere skies in June. So I'll send out more information on that during the month, but I'm really excited about it, and I really hope y'all can join us next month because I think it'll really be fun and unique. So enough of that. Anyway, so with that, I am done, and I will now go to the chat, and I will see what the questions are. Okay, so Krishna, he asks, I am planning to be at Joshua Tree National Park in Southeast California next week on New Moon Day. Does anybody have any experience stargazing there? How good is the stargazing? Yeah, I've never been there myself. I don't know if anybody else online has. My daughter and son-in-law have. They say it's wonderful. Has anybody online been out to Joshua Tree? Can provide some firsthand knowledge for Krishna? Anyone? Did you have any other questions, Krishna?
Well, I actually have been there.
Oh, I'm sorry. Go ahead, Rich.
No, that's fine. I was there with my son a couple of years ago. It was really awesome. It was great. The one thing that I would highly advise if you're not good at picking out the constellations, you mentioned it, Chris. The apps like Night Sky or something are super good. So they just really help you pick out the constellations. But it was fantastic. It was a great dark skies. So.
Any other questions,
Yes,
Krishna?
Chris, this is Krishna. I have a very basic and novice question. You mentioned that the precession is every 26,000 years, right?
Yes.
For 13,000 years, are we closer to the sun, and 13,000 years we are away from the sun? Is that true, or am I mistaken?
I don't know. It's just the orientation of the Earth will change. Parts of, I believe, in our position relative to the sun should not materially change due to precession. Parts of the Earth will be orientated differently towards the sun.
Okay.
Yeah. I hope.
Yeah.
I don't want to get too close to the sun. Okay, let's see. Anything else, Krishna?
No. What about the Milky Way core in Joshua in May, mid-May? Can you see the Milky Way core? Or is it too early?
Well, so what you can do during prime time, it will be, but if you wait longer into the evening and into the morning,
right,
you may have a shot at it. Yeah.
Okay. Thank you, sir.
You bet. Okay, Dan, you commented handouts and useful information. Okay, I think that was more of a comment.
Yeah, it's a comment. There is a lot that everybody could benefit from on the Astronomical League site. I want to congratulate you again on a very impressive tour of what we can see. Now, I want to caution everybody who has listened to this wonderful talk that when you go and look at the same galaxies with your telescope, you will not see the beautiful picture that Chris mentioned, and you will not have his very insightful information. So my suggestion is that since we have now star parties organized by various club members, very experienced, nearly every week, I would suggest you go to the events on our website, and you will see that there is plenty of opportunities to try from wherever you are. But of course, wherever you are, we will not compete with the dark side. Thanks again, Chris. That was absolutely fantastic.
Oh, absolutely. Yeah. Well, thank you, Dan. And that's a great point. You know, we do have opportunities to go out and stargaze. Dan is very heavily involved in that, along with some other club members. So look on the website and take advantage of those opportunities. I mean, the one thing that, I can kind of talk about these during our quarterly meetings, and I enjoy doing so, but there's nothing better than getting out there under the stars and actually, putting this into practice. I hold these what I do during the wintertime is I try to hold these novice labs with small groups so that we can really put our stargazing and our navigation of the night sky into practice. And I'll continue that on using the prime nights that we have each month. But it's really important to get out there and to get help because we've got so many club members that go out and routinely set up at the dark site, and they're so willing and able to take in a newcomer and just share their knowledge. So it's a great way to learn, and you can't replace it. I learned so much from the other members that it's really a wonderful experience, and it helps to help you get you on your journey. So thank you for that, Dan. That's a great resource. Michael Rapp says, I'll be at TSP in 2 days, and 95% of my targets are galaxies in Virgo and Leo. Excellent. Anything to add there, Michael?
Sure. You were mentioning, M51 earlier. The best view of M51 I've ever had in my life, repeatedly, has been out at the Texas Star Party. It literally looks like a rose. It is so detailed, and every time I stop by, I'm only going to look at it for like 5 minutes because I want to get on to some dimmer galaxies. But I always end up just staring at it for a good half hour. It's just that detailed and that beautiful.
That's excellent. So that's another opportunity to go out and view. And West Texas has got some very clear skies, so it's.
I want to echo what Mr. Rapp just said. I went to TSP for the first time last year, and I captured the best images of my entire astro imaging journey of M51, M101, the Sombrero Galaxy. And we had very good luck last year. I mean, every night was clear, and that may or may not happen. But being able to explore the sky from the Prude Ranch was an experience I never believed I could have. And the tour of the McDonald Observatory,
yes,
that is offered, to the TSP participants is amazing. So I encourage anybody to do that. And again, sir, your presentation is amazing. Thank you very much.
Well, thank you. I appreciate that. Got a question here from Rich. From your slide of the position relative to the galactic plane, if I understand the slide, it seems like the Milky Way is not visible in the night sky in the spring. Is that correct? So it is. What I've kind of set up as a calibration is the early part of the evening, so 8 to 11. Now, as I mentioned earlier, you can get views of the Milky Way if you stay up later, because eventually that will come into view. So it is possible. It's just you're not going to be able to go out and photograph it from 8 to 11 at night. You're going to have to wait until maybe 2, 3 in the morning. And that's why the apps are really neat on your phone, because you can see where the Milky Way is. And if you dial up the time, which you can adjust on say Sky Safari, you can actually see where the Milky Way when the Milky Way will come into view. So I hope that answered your question, Rich.
Yeah, that does. Actually, that's a really good slide, because I had just kind of assumed in the past that the orientation of the ecliptic was kind of in the plane of the Milky Way. And that slide shows it's not, and I get what you mean. Why? Yeah, it's not in the sky, let's say at the core viewing times, but it would be later on as kind of the Earth kind of rotates and the Milky Way kind of comes into view. So that's a great slide. I really appreciated that.
You bet. All right, let's see. Ward, thank you. Let's see. Spencer Pratt. I'll be very interested in hearing the information about Australia. I'll be there in December, and we'll probably get a ride out to the really dark sky in the outback. You were breaking up when you were talking about having the information, so I didn't hear it when I was going to present. So I'm going to put this together between now and the 1st of June. And so this will be the topic for the June novice meeting. And I was able to go out to Uluru, which is formerly known as Ayers Rock. They have some really dark skies out there. Unfortunately, the night I went out there, it was cloudy, or it had clouds. So that night wasn't too fruitful, but the tour that I took, the guys that run the tour gave me some pictures of nights that they were out there when it was clear. I did capture, believe it or not, 7 objects with my dwarf mini telescope in Katoomba, which is just west of Sydney, and in Perth, of all places, at a hotel pool deck. And I know it sounds weird, but the lighting and the orientation turned out pretty darn good in Perth. So I've got those objects. I will be putting all this together, and again, I hope to do it justice because the southern sky is so cool. It's the second time I've seen it, and I really get a kick out of it. So look for it June. I can't remember the exact date, but it'll be the first Thursday in June. Okay. And if you want any tips on going down there, I'd be more than happy to share with you one-on-one any questions you'd have, Spencer. So feel free to reach out. Thank you for your comments, Jeff. Hunter, thank you for the presentation. Just joined HAS. I'm a real novice with astronomy, but I'm looking forward to learning all that I can. Well, you've come to the right place, and I'm still learning. So what I would encourage you to do, Hunter, is you can certainly reach out to me via email. Anytime you want, you can always reach out to the club. Attend these meetings. I'd go to Prime Night for sure if we've got good weather for that, and you can learn a lot by just talking to the folks in the club. So yeah, welcome. I'm glad you're here, and I'm pretty new myself, so it's always good to have new members into the club. So welcome. Spencer, thank you. Excellent. I appreciate your comments. Okay. I don't have any more questions in the chat. Are there any questions or comments from the floor that anybody would like to ask or just make a comment on? Okay. I'm going to do my auctioneer imitation here. I'm going to say going once. Going twice. Okay, we're done with our meeting tonight. I thank you for joining tonight. I hope you enjoyed it. Sounds like we got some value out of it tonight, and I look forward to seeing you all at the June meeting. So with that, I will bid you farewell, and I wish you a pleasant weekend. Thank you.